Everyone, in this video we're going to look at the bisection method, which isn't overly complicated. It's just something a little bit different and you're likely only to see it with pseudocode, but in this video I just want to cover what the bisection method is so you get an understanding before we actually then couple it with pseudocode. Alright, so if you think of the term bisection, so bi meaning two, like a bicycle, and then section means we're just splitting it into two sections. So basically what we're doing each time is just finding the midpoint. We're separating the distance between 2 points into two. So my dog is just having a drink of water. I don't know whether you can hear her slurping in the background, but it's quite funny. So this diagram here actually shows what is happening. Let me just get my little pen. All right. So we've got some curve and this one's just been drawn roughly. And what we do to start off with is we choose 2 points. So here it's just A and B. And the ultimate goal, now she's doing something in her dog bowl and her food, all right, is to find this x-intercept. And we can do it some sort of tolerance level, which we'll discuss when we start doing some examples. Let's just focus on what the bisection method is. So what we do is we look at the distance, right, between A and B, and we find the halfway point. All right, so the halfway point isn't that red dot. It does look like it's halfway, but it's just kind of to the left of halfway. So halfway is actually this point here, B, which is called B2. And what we do with the bisection method is we keep decreasing that range of values by finding the midpoint. So then the next one we're going from A1 to B2, and then we're going from A2 to B2, and then we're going from A3 to B2, and that range gets smaller and smaller, and it means we're getting closer and closer to that x-intercept. Now, there is a way of deciding which side you're going on. So if you're sitting there and thinking, well, how did I know to do the halfway of point of this left side and not this right side? Right, and it all has to do with the sign of when you multiply your y values, basically. So when we do an example, I'll show you how you decide which side you're going on, and that actually has applications in pseudocode. So it's very important you understand what is actually happening there. So I might just get rid of that. All right, so we do follow these steps. I might just leave that on the screen in case you want to copy that down. So you can just pause and copy that down. All right, there's a pseudocode question which we might come back to. But I just thought in explaining the bisection method, I thought let's just have a look at this cubic graph. Now we've got 3 x-intercepts and we can clearly see what they are, but I thought let's just choose an easy example to figure them out. All right, and I'm going to find this value here, or approximately what that value is. All right, so not the other two, just that one. All right, and I'm going to start off with 2 and 4. So I can see it's between 2 and 4. So when you're doing pseudocode, it'll actually tell you which 2 values to use. So we know it's between 2 and 4. All right, so I'm going to start that on this side. So our starting values, let's just call them A and B. All right, so our starting values are 2 and 4. All right, I hope that makes sense. So 2 and 4. All right, so we're going to find the midpoint of those 2 points. So the midpoint of 2 and 4, easy, it's 3. All right, if you didn't know what it was, you can just add them together. Divide by 2 is another way of getting your midpoint. Now visually, we can see that our dot is still between 2 and 3. All right, that x-intercept is between 2 and 3. And if you're given a function, which you usually are, you can actually use that position to help you work it out instead of just following the pseudocode. But let's, when we do pseudocode, I'll explain that. All right, so this time, so this 3, so your midpoint either goes on the A side or on the B side. And we can see that it's going to go on the B side because the point is between 2 and 3. All right, so the 3 goes on the B side. So now we're going to look at the midpoint between 2 and 3. All right, so we're going to do that. So it's going to be 2.5, 2.5. And my graph, it's a bit hard to see, but we know it's 2.5 is there. So I can see it's still going to be between 2. So the 2.5 is going to go on the B side, 2.5, and the 2 stays on that side. So then we're doing the midpoint of those 2 points. So we're getting, that range is getting smaller and smaller. So now we're going like that. All right, so halfway between 2 and 2.5 is 1.25. Now it's a little bit hard now to see what it is on my graph. So this is where the bisection method actually comes in handy. All right, so I'll explain it. I'm going to have to just go off my scribbles here just so we can see. All right, it's important to note where you are positive and negative on your graph. All right, so this is what the bisection method is. So you can't do all the time what I've just done on the right-hand side, right? Even though hopefully that would make sense, because we're going to get to a point where I can't actually see where, I can see where 1.25 is. Actually, let's just finish that one off because I can see just with the scale. So this time it's going to go on that side because 1.25 is here. You can just see where I put that on. All right, that little marking there. So it's going to be, oh, not 1.25, sorry guys. Oh my gosh, 2.25. This is why you should always watch my videos in full and never pause because sometimes I make mistakes. All right, 2.25 and 2.5. All right, so we're going to do halfway between those 2 points. Now, if you get to the point where you can't figure out what the halfway point is, you can just add them together and divide by 2. So I'm just going to do that on my calculator now. So 2.25 plus 2.5 gives me 4.75, and then if I divide by 2, I get 2.375. 2.375. Now at this point it's a little bit too hard now for me to see where my range is going to go. All right, so what I was saying before, it's important to know where you are above and below. So let's do yellow below. Oh no, that's not very, can't really see that. Let's do green, might be a bit easier to see. All right, so we're going to see how that part of your graph is below, and there's more, but we're just going to focus on this section. And then, whoops, why am I doing green again? Let's do, oh no, not orange. Oh, choose a color I haven't done. All right, let's do this pink. All right, and that's above. And that's important to know because what we have above, all right, so this is all your y or your f. All right, so remember f is the same as f of x. So here we have f of x is greater than 0. It is positive. And below we have f of x is less than 0, so it's negative. And the sign is extremely important. All right, and I'm going to write that just on the side here because this is what the bisection method is. So we don't always graph it. I mean, you can graph it and see it, but when you think about this graph, it's quite easy to see, but on a calculator screen, a little bit harder to see. So what we would do is we would say, all right, let's have a look at f of 2. All right, so we've got f of 2, and we're going to multiply that by our midpoint. So f of 3. All right, so basically f of A times f of C, so C being your midpoint. Now, if f of 3, all right, so I've got f of 2, and I can see that's in the green section. I've got my function down the bottom here, so I could use that, but it's going to be very time consuming. But I can see it's in the green section, so it is actually negative. So f of 2 is negative. F of 3 is 3, so it's clearly above the axis, so it's going to be positive. So I'm multiplying a negative by a positive. All right, so I'm going to get a negative answer. So when I get a negative answer, that tells me that, all right, I have to keep this negative side the same and move the other point. In the bisection method, it'll actually tell you which way to do it. All right, so I'm not going to go through those other steps. Let's have a look at this last one. So f of 2.5. So dog's barking. All right, times f of 2.375. All right, and I'm just going to define this on my calculator. All right, so I've gone ahead and defined it. All right, just pause the video because it was going to take a while to do. All right, so then we're going to do, f of 2.25 times f of 2.375. All right, and I get a negative answer. So it's kind of like what I was doing up here. So we're going to keep that negative value, right, the on the left side, the A. All right, so 2.25, and then my midpoint goes to 2.375. All right, and we're going to repeat that again, and I might keep doing it just to show you what I just did. So again, we're going to find the midpoint, 2.25 plus 2.375, just finding the midpoint now, so divide by 2, and we get 2.3125. All right, so on my calculator, all right, I'm going to do f of 2.25 times f of c, so not A and B, it's f of c, so 2.3125. And see what I get. $2.3125. So this time I got a positive answer. So what that tells me is that I'm going to take my midpoint and put it on my A side. All right, so 2.3125. And then we're going to keep that B, so 2.375. All right, and then we find the midpoint again, and we can keep going and going. But I'm just going to stop there because we'll be here forever. So what we've got is, we know the midpoints between there, 2.3125 and 2.375. So if I have a look back on Desmos, here's the graph, and there it is at 2.333. So basically we could keep going, finding that midpoint until we get to 2.333. All right, so it's a long process to do. If you can visually see what it is, it does help you. But when you get down to the nitty gritty, it's a little bit harder. So that's, I guess, why it's good to understand what the pseudocode is actually doing. All right, let's have a look at this pseudocode question. All right, I don't know where this was taken from, but it is a bisection. So with pseudocode, you could get a Newton's approximation, you could get a bisection, or you get something completely different. So in a separate video, we'll do pseudocode. All right, so we've got an algorithm below, which uses a bisection method. So we'll actually define the bisection method for you, either there, or it could be in this define part. All right, so we've got the bisection. So you'll get familiar when we do the pseudocode video. All right, to estimate the solution to an equation in the form f of x equals 0. So we're finding the x-intercept. All right, just like we did before. All right, so these inputs, it's basically just explaining what everything is. So we've got f of x, which is a function, and if we go down a little bit, all right, there's our function there, it's sine x. It's told us it's in radians, right, which is good because we could put it in degrees as well. We should assume that it's in radians because we tend to work in radians unless we're actually finding the angle of something. All right, A is your lower interval endpoint. So remember, if we've got our axes, we're going to have A here and then B. All right, so A is your lower, B is your upper, and max is your number of iterations. So what we've got here is the defined algorithm. So we've got f of x is sine x. A is 3, so we can say 3, and B is 5. And the number of iterations we're going to do is 2. So 2 iterations. All right, so we're going to run through this pseudocode twice. All right, so we're going to basically apply the bisection method twice. Now, we did it quite a few times. All right, so I don't even know how many. What is that, 6? 6 times? All right, you wouldn't have to do it 6 times because it's just a matter of understanding what the pseudocode actually is. Now, with your pseudocode, you don't have a starting value like you do with Newton's. You have 2 interval points. All right, so we've got 3 to 5 and a number of iterations. So just make sure you read what it's actually asking. So what value would be returned when the algorithm implemented is given. So basically once we've done our 2 iterations. All right, just having a look at what this pseudocode actually is saying. So I might highlight it in a different color. So remember we were doing f times a times f times b is greater than 0. So if it was greater than 0, that just means you've got 2 y values that are basically above your x-axis. So a positive times a positive gives you a positive. So that's why you've got invalid interval. All right, you want something below, which is negative, and something above, which is positive. So then you get less than 0. All right, so basically that's what that part means. All right, we're going to start with 0. So we're going to do 1 iteration first of all. All right, so we've got to find the midpoint. All right, so a plus b divided by 2, which is what we did before. So let's just have a look at doing that over here. So I'm going to keep it the same as we did before. So 3 to 5, and the halfway point is 4. All right, so your midpoint. Now, if your midpoint, f of mid, is equal to 0, then we return mid, and if not, we keep going. Now, we can see that we actually get a value, and if we did, that was our starting midpoint, all right? So if I was to do sine of 4 and got 0, well, not that you would, because it's not 0, but if it was, that would be our midpoint. All right, so we can just check it on our calculator. All right, I might just do define on the calculator to see. So define f of x equals sine x. I'm in radians. All right, so we're going to do f of 4. All right, so it's not 0, so that's not our midpoint. So if it was 0, that would be our midpoint because f of 4, if it's equal to 0, that is our x-intercept. All right, so then we keep going. Now, what this next part is basically saying, well, let's just check where things go. So f of a times your f of your midpoint. So we're going to do f of a, which in this case is 3. All right, keeping the a on the left-hand side, times f of your midpoint, which is 4. And we get a negative value. All right, we just need to know whether it's positive or negative. So this one's negative. So if it returns a negative value, then b now becomes our midpoint. All right, so our midpoint is going over to b. So we keep a as 3, and then 4 now becomes our midpoint. So if you think about here's 4 in the middle. All right, we've checked whether we've gone from 3 to 5. We know it's between 3 and 5, and now we've shortened that distance to 3 to 4. And then we start the process again. So we're going to find the midpoint between 3 and 4, which is 3.5. And then we're going to do f of 3 times, so it was always a times c, so f of c, which is 3.5. All right, and it's negative again, so that 3.5 is going to go over there. And the value of a stays the same. All right, so we've done our 2 iterations. So basically, let me just get a highlighter. This is our first iteration. So applying the 4 here. So that b became 4. And then the next change here was 3.5. So if we just go back to have a look at our might just recircle that in a sec, to our pseudocode. So we only wanted to do 2 iterations, and this is how it ends. So you're either applying your mid to B or your mid to A. And because we'd already gone through the first iteration, our second iteration, the midpoint was B, 3.5. All right, so we stop there. So we don't put in what the new midpoint is because that is back up here at the top of our algorithm. So we just stop at 3.5. So the answer is D. So visually, it's probably, I think you can use pseudocode, but it's probably a good idea to see what it actually looks like on your calculator. So I'm just going to get my calculator up to show you. All right, so here's the graph of sine x, and you can see we're going between 3 and 5. Now, if you are unsure which value to make your midpoint, you can easily see there when it's 4 that it's the value of b that changes. So it went from 5 to 4, and then 4 to 3.5, which is going to be here. And then if we did another iteration, it would go to 3.25. All right, because I think that intercept there is somewhere between 3 and 3.25. But we only had to do 2 iterations. Remember, the max was 2. All right, so we're stopping at 3.5. All right, so in the pseudocode video, we might do some other bisection method questions, but it's probably a good idea to have a few examples in your bound reference. All right, bye guys.